I'm Anil Kumar. Welcome to my series on directed numbers. We'll discuss what are directed numbers, are the directed numbers and the integers same, how to add directed numbers with same sign, how to add directed numbers with different signs, how to subtract directed numbers, multiply directed numbers, divide them, and also we'll see a few order of operations. So let's begin with directed numbers themselves. So when I say directed numbers, it means what? It means two things. One, the number which has sign, right? And second, it has a magnitude. Those numbers which have sign and magnitude, they are directed numbers, correct? So let's give some examples for these numbers and the ways in which we could write and represent them. For example, if I write plus 7, so positive is a sign and 7 is the magnitude. We could write minus 5, right? So that becomes a directed number. Numbers could be like minus, let's say 40. Right, so that is a directed number. We could also write a number like plus 35. It is not necessary to put the brackets. So even if we write like this, it becomes a directed number. Well, if I write 100 here and there is no symbol sign, it is assumed to be positive, right? So it is positive 100. Now these examples which I have taken are all the integers also. However, directed numbers are numbers with any magnitude, not necessary integers. Perfect. So I could write minus 2.5. Now this is not an integer, but it's a directed number, right? So as you can see, I'm not really writing this as minus 0.05 in the brackets, right? So it is, you may or may not use the brackets. That's what I'm trying to say. Perfect. But they may have sign or they may not have a sign. That is what we are interested in. All these numbers are directed numbers. Now there are so many ways in which they have been used. For example, one of the applications is in the temperatures, right? You see positive and negative temperatures. You see profit and loss, for example. We can use directed numbers, debit and credit. So many examples. We could have some word problems in which we could see directed numbers. Even when we see movement, right, we may say position. Now, position is kind of important. When we are considering position, we may assume that there is a number line, for example, right? Now, on a number line, we'll consider 0 as a placeholder for the numbers on the left of this will be negative numbers, right? And on the right of it will be positive numbers. So all these directed numbers can be represented on a number line, and they're always increasing in this. So numbers on the right are greater than the numbers on the left. So they are increasing in this direction, and of course they'll be decreasing when you move from right to left, right? So to give you an example, we could have a number which is minus 1, minus 2, minus 3. On the right side, we'll have like 1, 2, 3, and so on, right? The arrow indicates that they are infinite numbers. Numbers in between, we can have 1.25, we can have a minus 2.5 or anything. So all these numbers are directed numbers. Is that clear to you? Now I hope we have also answered the second question. So we know what the directed numbers are. They have sign and magnitude. If there is no sign, it is assumed to be positive. Second thing is, are directed numbers and integers the same thing? The answer definitely is no. Since, well, all integers are directed numbers, but directed numbers may not be integers. As we have 2.05 is not an integer, right? Minus 2.05 is a real number, not an integer. Okay. Now with that in mind, let's now see different types of operations which we'll be performing on directed numbers. So let's begin with how to add directed numbers. Now, in this particular case, we are going to have examples based on addition of directed numbers with same sign. So same sign means, so here we have an operator. So operation is addition. That operator, right? So that is the operator. And when we say sign, signs, we mean these signs. Do you see that? So we see these signs are all same signs. So that is what we mean by saying same sign. And addition means operation is addition. Is that clear to you? Now, if that is the case, then what is the result? Well, we will have more of the same. So this, when you add, we have more of the same. So that means we'll have the same sign. So the result will be same sign, higher magnitude. So absolute value will be higher, right? The number may not be the greater number, right? But the magnitude will be higher. When we talk about magnitude, we drop the sign, okay? Now, let's begin answering the questions. When we add 5, plus 5 is plus 10. Same sign means positive. It is positive 7. Just add the numbers, right? So basically, you need to add numbers and maintain the same sign. So if both are positive here, add and we get 10. Both are negative, add, we get 8. Do you see that? So both are negative. Same sign, negative, add 5 and 3 to get 8. Is that clear to you? So it is minus 13 in this case. This will be plus, same sign, right? And 9.5. And here, again, plus 6.1 and 2.2 will get 8.3. All plus, same sign, right? So let me write plus here. Just add them. 5 and 2, 7 plus 1, 8. And in this case, same sign. We have negative, right? And just add them. So in decimal, we have 3, 7, and 3, 10. Is that clear to you, right? So if you have the same sign and you're adding, you get more of the same, right? So remember, that results in more of the same sign. Clear? Okay. Now let's do the next operation, which is, now we're going to try to add directed numbers with different signs, right? So when I say different signs, do you see these two signs are different, right? That is what we mean. So these signs are different, right? So when they are different signs, then the result is what? So we see which number is bigger, right? So it takes sign of bigger number. That is what the result is. So in this case, when you are adding 5 plus with minus 2, sign of the bigger number is plus, 5 is bigger, and the result is difference of the 2. So the result is take away 2 from 5, which gives us 3, right? So what you get here is sign of the bigger number, and we have magnitude of difference. So it is going to be smaller, right? So magnitude of difference, so absolute value, right? So when you're doing minus 3 plus 7, now here you're adding two numbers with different signs, positive and negative. Bigger number is positive and 7 minus 3 is 4, correct? Here minus 8 and 5, bigger number is negative and their difference is 3. In this case, bigger number is positive and the difference is 5. Now here, the difference is positive number is a bigger number, and we'll do the difference. We get 11 take away 2 is 9, we borrowed. So 5 take away 2 is 3. Now in this case also it is going to be positive. Take away 1.0, we get 8.2 as our answer. Is that clear to you, right? So here in this case, the sign will be taken as that of the bigger number and the magnitude will be difference. Now you could also visualize this on a number line, right? So if I have a number line, for example, and let's do 5 minus 2. Let's say this is our 0, right? So 5 really means that we have these units 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the right side, right? So plus 5 means 1, 2, 3, 4, 5. You move to this place which is plus 5. And this is minus 2. So from here you get back to minus 2. So where you reach is this point which is plus 3. Do you see that? So that is the plus 3 operation. So you could use number line to perform these operations, right? However, we'll focus on algebra part more in this particular video, right? Okay, next let's see how to do subtraction with directed numbers. Now remember, subtraction is reverse of addition, right? So remember this, that subtraction is reverse of addition. So what we do here is we change the sign and do the reverse operation, right? So what we do here is that we change subtraction with addition sign and reverse sign. So it's kind of complicated. I don't really want to write too much, but I can tell you what we're trying to do here. So here the operation is, we have two numbers, plus 5 and plus 2, directed numbers. The operation is minus, which is subtraction. So we'll do reverse of this sign. So when I reverse the sign, then the sign of the directed number changes from plus 2, it becomes minus 2. Does it make sense to you? So the operation being performed now is that of addition. Then you follow the rules of addition, right? You know how to add them. The sign of the bigger number is positive and the difference is 3. So that is the result. Is that clear to you? So when you have to subtract the numbers, first step is to reverse the sign. And when you do that, both the signs get reversed, right? So we have minus 3 and that minus becomes plus. This minus also reverses. Now you do addition, right? So now you do addition. And now addition of 2 with different signs. Positive sign since 7 is bigger and their difference is 4. Is that clear to you? That is how you do it. So let's complete this exercise. So we have minus 5. Reverse these signs. Is that okay? Both changed. Perfect. And now we do addition. Minus is bigger number and the difference is 2. Is it clear? Reverse both these signs, right? So make negative as positive and positive as negative. Clear? Now you add them. So adding the same signs, negative, more negative, add them to get 13. Here, reverse these signs. That's what I mean by reverse sign, right? So just make them both positive, right? Reverse these signs. Now once you do that, now it is addition with same sign. So just add them, plus both are positive, and we get 5.3 as our answer. Here again, we'll reverse the sign. We get 8.5 plus minus 9.0. Now in this case, negative number is bigger, so we get negative sign, and big difference between them is 0.5. Is that clear to you? So that is slightly tricky, but the idea here is to work on these two positions, right? Reverse these signs. So whenever you are subtracting directed numbers, reverse the sign and then perform addition, right? Since remember, subtraction is reverse of addition. Okay? Now, let's talk about multiplication. So let me write multiplication. We have written integers, but let's make this as directed numbers. Remember, integers will not include your decimal numbers, right? So directed numbers are actually numbers with sign and magnitude. So all real numbers are directed numbers, right? So our focus is on their operations, which are similar to that of integers, right? So the techniques involved are same as those in integers, okay? So that is how they are similar. When you multiply, what really happens? Well, the two numbers which are getting multiplied, they could have same sign or they could have different sign, correct? So the signs could be positive or negative for these numbers. If the signs are same, then the result is positive, right? So, sorry, negative. So if the signs are same, then the result is positive. Otherwise, with opposite signs, it is negative. Clear? So this is kind of simple to understand. So if you multiply same sign, it results into positive. If it is opposite sign, that results into negative. Is that clear to you? Right? So that is how we get the sign. Multiplication is exactly similar to what you've been doing, right? So first look into the sign. Both positive means same sign. So the result has to be positive, and 5 times 2 is 10. One positive, one negative. Result has to be negative, and the answer will be 21. Now look here. Multiplication operator could be this. It could be a dot, right? And even when we write two brackets like this, then also without anything in between means multiplication, right? So remember that part. Now these are same signs, so it becomes positive, and 5 times 3 is 15. Here we have again same signs. Result will be positive 40. Negative is positive. Different sign, the opposite signs gives us minus. And 6 times 2 is 12. Now same sign means plus 1 times 8.5 will be 8.5. Now in this case, we actually have three numbers. Positive, positive, one negative. But, this will give positive, that will give negative, and we get 10. Now, when there are a lot of numbers, what we look into is odd number of negatives. So, odd number of negatives result negative. Is that clear to you? Else positive. So if there are even numbers, like of negatives, just count negative numbers. Now here we have three negative numbers. So odd number of negatives will result into negative. You get the idea. Multiply 5 times 2, 10 times 3, 30. Is that clear to you, right? So as an exercise, what you could do is you can multiply these numbers. Let's make it like this. That should be equal to what? Now in this particular case, we again have odd numbers. Let me just multiply this by minus 2 once again. So we have 1, 2, 3, 4 even numbers of negative sign. So the result is going to be positive. You get the idea, right? So 5 times 2 is 10, 40. 40 and this is 6. So 4 times 6 is 24, 240. Correct? So that is how you could do the multiplication for directed numbers. Clear? So look for how many negative signs are there. If there are odd, then you get negative answer. If even, you get positive answer. Now division is similar to multiplication. So when we have odd number of negatives sign, then you get negative result. And if we have even number of negative signs, that will result in positive, right? So now in this case, we have 2 positives, so definitely positive, right? No negatives. 0 negatives means positive. And we have to divide 6 by 2, so we get 3. 21 divided by 7 is 3, and the sign will be plus divided by minus 1. Negative means odd number of negatives, negative sign. Now here again, 1 negative, negative sign. Now 12 over 16. So you could divide this by 4 and you can get 3 over 4, right? So you could also write this as 0 point, that becomes 7, 5, correct? So you could write this in decimal numbers also. Now this is not an integer, and that is how directed numbers are different from integers. When you divide two negatives means even number of negatives. You get positive. 40 divided by 8 will be 5. Here 2 negatives means positive. 6 divided by 2 is 3. And here 1 negative, odd number of negatives. So minus 1 over 3 is your answer. And in this case, when you have a lot of divisions, we have to move from left to right. So in this case, move from left to right. So that is order of operation, right? We'll take up a video part on this also. Odd number of negatives, so the answer has to be negative. So first let's do these two. So 60 divided by 3, so when you do these two, you get 20, right? And then you have to divide 20 by minus 2. Now that gives you minus 10. Is that clear to you? So do it in steps. So, and move from left to right. So here, move from left to right. So let's do this first. So when you do this, you get minus 3 over minus 5. So basically, you get 3 over 5. And then you have to divide by minus 2. Now that was 2 negatives making it positive. However, this is 1 negative making it negative. So we'll multiply by, you can say divide by 2 or multiply by minus, right? So that is 1 negative. So we get 3 over 10 with a negative sign, which is same as minus 0.3. Is it okay? So here we get minus 0.3. I'd like you to do this exercise on your own once again. The last page here will discuss about order of operation. So in US we say bed mass, right? Or we also say parenthesis for P, bed mass, either one of them, right? So this means brackets, exponents, division, multiplication, addition, subtraction. This is parenthesis, which is same as brackets. Okay, so that is the order of operation. Kind of important here is that when we say division and multiplication, their status is same. So whenever both operations are involved, even addition and subtraction, you do from left to right. Okay, so not necessarily you'll do division before multiplication, okay? They are at same power. Now let's look into this. Example, 2 plus minus 3 plus 6 divided by plus 2. Now here, we have this division thing, so we'll do this operation first, right? Not this. We'll just write this as 2 plus minus 3. And dividing two positive numbers will give us 6 positive, right? So we get 6 divided by 2 as positive 3. Now we have addition and subtraction. So what we are going to do is we are going to do from left to right. Is that clear to you? So 2 minus plus 3 is minus 1 plus 3, and that gives you plus 2 as your answer. Is that clear to you? Next one. First part is the exponent. So 4 square is 16, and rest, let me write like this itself, right? And now we are going to perform the division part. So we can write this as 16 plus minus 3. And here we'll divide 6 by, now look here, we have 3 times plus 6. So that is multiplication, this is division. So we'll have to multiply first. You get the idea, right? So what we should do is that we'll multiply minus 3 with plus 6 first. And then we are going to divide this by minus 2. Do you get the idea? First you have to multiply that, right? So let me rewrite this as 16 plus. Now multiply this, we get 6 times 3 with a negative sign gives you minus 18, right? Now minus 18 will be divided by minus 2, which is plus 9. So we get 16 plus 9 as 25. It is not necessary to write in denominator as I did, but you could. Next question here is square root of 16, that is an exponent. This is also an exponent. Let's do that. Square root of 16 is 4 minus, and we have minus 16 here, divided by exponent, right? Minus 2 to the power of 3 is minus 8. Now that is division. We have to do that first. So we get 4 minus, and minus 16 divided by minus 8. Let me write like this. Minus 16 divided by minus 8, right? It becomes kind of clear. So what you get here is 4 minus minus becomes positive, but however, we have this negative sign here. 4 minus 2, the answer is 2. Now this step you could avoid. I'm only introducing this step to you so it becomes more clear. The last one here is multiplication and division. So remember, we write DM, division first, multiplication later. However, they have the same status. We always move from left to right. Remember that, right? Left to right. Otherwise, you might do a mistake. So we'll first multiply, then divide. So 6 times 3, both positive, means 18, which is positive. And we are going to divide this by negative 2. It's positive and negative. One negative sign makes it negative result. 18 divided by 2 is 9. So we get minus 9 as our answer. Is that clear to you? So that is how we actually do order of operations with the directed numbers. So in this exercise, we learn what are directed numbers? Any number with a sign and magnitude. Directed numbers are not the same as integers. Integer is a subset of directed numbers. All integers are directed numbers, but vice versa is not true, right? So you can say all integers are directed numbers. Reverse is not true. Right? So all directed numbers are not integers, right? So these are all directed numbers, but they are not integers. Okay. Then we learned how to add directed numbers with the same signs. We get more of the same. But when we add with different sign, the sign of the higher number is maintained, but we get a lower number as a result. When we add directed numbers with different sign, right? And when we subtract directed numbers, we first reverse the sign. So first we reverse, make it addition, right? And then reverse, right? Positive to negative, negative to positive, and then you do addition. Multiplication and division are similar operations where we know that same sign, positive. Same sign means positive, opposite sign means negative result. And then in order of operation, we learn how to do the BEDMAS, where it is important to understand that division and multiplication has same order as, so it goes left to right, and addition subtraction also has same order, so always do left to right. Okay, so with that we come to an end of this video. I hope you got the basic concepts. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.